Hi, this is Anthony Purcell, and I'm sitting with my Math 1325 class. We are determining concavity for a function, and here's the function. F of x equals negative 2 over x plus 2. We want to determine concavity and any points of inflection. In order to determine concavity, what do we need to find? The second derivative, and before we find the second derivative, we need to find the first derivative. And before I start differentiating, the way this is written, you might be thinking quotient rule, but I try to avoid that quotient rule whenever I reasonably can, and I can do that now. I can avoid that by rewriting this using a negative exponent. That's a negative 2 times x plus 2 to the negative 1 power. Recall your properties of negative exponents. I don't see an exponent on that, so we assume it's a power of 1. To write it using a negative exponent, pick it up, move it up out of the denominator, change the sign. So differentiating this, we get f prime equals negative 1 times negative 2. I agree with 2 times x plus 2 to the negative 1 minus 1, I agree with the negative 2, times the derivative of the inside stuff. We're using that generalized power rule. The derivative of that inside stuff is just a 1, so all we have is a 2 times x plus 2 to the negative 2. Now what? Find the derivative. Differentiating again, we get f double prime equals negative 2 times 2 is a negative 4 times x plus 2 to the negative 2 minus 1. I agree with negative 3. And the derivative of that inside stuff is still a 1. So I would then translate this back to a statement using a positive exponent. How would I write negative 4 times x plus 2 to the negative 3 using a positive exponent? Okay, so it's a negative 4 over x plus 2 to the positive 3. Concavity can change when the second derivative is equal to 0 or undefined. So first of all, let's ask our question. When is f double prime equal to 0? I said this the last time. A fraction is equal to 0 when the numerator is 0. When is the numerator equal to 0? Never. Negative 4 never equals 0, so when is f double prime equal to 0? Never. Next we ask ourselves, when is f double prime undefined? When the denominator is equal to 0, well, when does x plus 2 cubed equal 0? Okay, when x is equal to negative 2. So, if concavity is going to change, it will change at negative 2. We draw our number line. There's negative 2. We're looking at the sign of f double prime. To the left of negative 2, what do y'all want to check? Negative 3? I couldn't hear you. Is that what he said? Negative 3? What about to the right of negative 2? What do you want to check? 0? Well, I guess I should ask, what do you think I'm going to check? I'm going to check 0. So, plugging in the negative 3 into the derivative, the second derivative, we get a negative 4 over negative 3 plus 2 is a negative 1 cubed. Positive or negative. The exact value doesn't matter, just positive or negative. I agree. Negative divided by negative, that's going to be positive, so concave upward. And plugging in 0, we have a negative 4 over 0 plus 2 is just a 2 cubed. Positive or negative? Negative. so concave downward. And they want us to determine concavity, so we need to determine when the graph is concave upward. When is it concave downward? And any point of inflection. Concave upward, remember we defined a graph to be concave upward if the second derivative is greater than 0. Those are open intervals. So from negative infinity up to negative 2. Concave downward from negative 2 to infinity. Point of inflection. Take that negative 2 and try to plug it into the original function. If you plug it into the original function, where's my original function? Right here. If you plug in negative 2 into the original function, what are you going to get as the y value? Are you going to get a y value? No, you'd wind up with negative 2 over 0. If you tried to plug in negative 2 into the original function, you'd get negative 2 over 0. That is not a number. Therefore, there is no point of inflection. What's happening at x equals negative 2? We have a vertical asymptote. A vertical asymptote at x equals negative 2. And a graph can change concavity on either side of a vertical asymptote. Any questions there? But if you try to plug in that negative 2, I don't remember what the number was when we did this a similar problem in class on Tuesday, but the question after class was, why was there no point of inflection? There was no point of inflection because if you tried to plug in that number that we got where concavity changed, we didn't get a real number back for y. We got an undefined result. Any questions?